Hi, this is Chris Overholt, and in this screencast I'm going to show a video tutorial of how to create a basic FDS input file, run the file, and view the results in SmokeView. So let's get started. First, I've created a basic specifications document which gives an overview of what I want to build in my model. So I'd like to have a 4x4 by 2.4 meter room. Those are the dimensions for the domain that I'm going to use. I'd like to have 10 centimeter grid cells, uniform on each side, and I'd like to have it run for 15 minutes of simulation time. I'd like to have open boundaries on all sides except for the ceiling. This means that on the four sides, the left, right, front, and back, I'll have an open boundary to ambient conditions. And I'd like to have a 500 kilowatt fire placed on top of a 2 by 2 by 1 meter obstruction in the middle of the room. Some output quantities that I'll include are basic output quantities, a temperature slice file in the middle of the room in both the X and Y directions, and a couple of boundary files which are going to paint all of the boundaries with the wall temperatures and the wall heat fluxes, both radiative and net heat fluxes. So let's get started. The first thing I want to do is right click, go to new folder, and I'd like to make a new folder. You can name it whatever you'd like. I'll name it room, and this is where I'm going to save my FDS input file to, and all the output will go in here as well. Now I can go to start, run, and I can type notepad, click OK, and you can use notepad or your favorite text editor here, just a plain text file. So first thing I want to do is type ampersand head, and the first parameter is chid equals to room, and this is the job name, room, and this is what the output files will be named: room.smv, room.csv, and various output file names. The next parameter is title, and I'm going to name it room fire model. You can name it whatever you like for your reference, and I'm going to type a slash at the end of that line to say that I'm at the end of the head name list. Next, I'm going to type ampersand mesh, ampersand mesh, and there are two parameters here to use: ijk equal to, this takes three numbers, I'm going to put 0, 0, 0, just to show you how to calculate those numbers. And the next parameter is xb equal to, this takes six numbers, so I'm going to put 6 zeros in and show you how to create the dimensions that we want, and a slash at the end. So at this point, if I want a 4x4 by 2.4 meter room, I have six numbers here. The first two numbers are the x dimension, the length. The next two numbers are the y dimension, the width, and the last two numbers are the z dimension, or the height of the domain. Now this includes my entire computational domain, which in this case is the same as my room. So I'll type 0, 4, 0, 4, 0, 2.4, and this represents a 4 meter in length, 4 meter in width, and 2.4 meter in height domain. Now the ijk is an important parameter where the x, y, and z number of divisions are given. So if I have a 4 meter room and I divide it into 4 pieces, I'll have 1 meter length pieces. I actually want 0.1 meters or 10 centimeters. So if I do 4 divided by 0.1, I get 40. The y dimension is the same, 4 divided by 0.1 is 40, and the z dimension is 2.4 divided by 0.1 gives 24. So this gives me 10 centimeter by 10 centimeter by 10 centimeter grid cells uniform in the x, y, and z direction. If I wanted to make the grid cells smaller or get a higher resolution, I would actually increase the ijk numbers. So if I wanted to double the resolution or make the grid cells 5 by 5 by 5 centimeters, I would actually input 80, 80, and 48 here, which is double. It would increase the runtime of my model, but I may get better results. So the next line I want to input is ampersand time, t underscore end equal to, so I want to run the model for 15 minutes, so that's equal to 900 seconds, and this input is in seconds. put a slash in the end, and I'm done with the timeline. So this tells my model to run for 900 seconds and then stop. The next line I want to put in is the obstruction. So my document specified a fire on top of a 2 by 2 by 1 meter obstruction. So to do that, I'm going to type OBST, which stands for obstruction, XB equal to 6 numbers. I'm going to put 6 zeros for illustrative purposes, and a slash at the end. And for this, this works the same as the mesh XB. This is 6 points, the X, Y, and Z dimensions of my obstruction. So if I want a 2 by 2 meter wide and long obstruction, if I simply put in 0 to 2, that's actually going to put the obstruction on the left side of the domain, and I want it in the center of the room. So what I'm going to do is use the center of the room as a reference point. So between 0 and 4 is 2. So if x equals 2, I want to go 1 meter on either side of that. So 2 minus 1 is 1, and 2 plus 1 is 3. So from x equals 1 to 3, I'm going to have an obstruction. That's 2 meters in length. I'm going to do the same in the y direction, 1 to 3. So from y equals 1 to 3, I have a 1 meter in width obstruction. Finally, I'm going to go from 0 to 1, that's from the floor, to 1 meter high obstruction. So those 6 numbers specify a 2 by 2 by 1 meter obstruction in the middle of the room. The next thing I want to do is input the actual fire, and I'm going to do that with 2 lines. Ampersand surf ID equals fire, and that doesn't actually tell it to burn. What does is HRRPUA, or heat release rate per unit area. I'm going to set that to 0 for now and show you how to calculate that in a second. The next line I'm going to put ampersand vent. I'm going to type XB equal to 6 numbers. I'm going to put 6 zeros for illustrative purposes, and then I'm going to type surf underscore ID equal to fire. And this is because it matches the previous surf ID equals fire and tells this vent to use that surface ID. So for the XB, what do I put in? Here I'm going to place the vent on top of the obstruction. So it's going to go on the same X and Y coordinates, 1, 3, 1, 3. So that matches the obstruction. However, on the Z dimension, I'm going to put 1, 1. And the reason is, if those match, I'm going to create a plane at Z equals 1 that's 2 by 2 meters in length and width. So this is actually placed on top of that obstruction. The last thing I want to do is insert the heat release rate per unit area. So I was specified a 500 kilowatt fire, and this is heat release rate per unit area, which is in kilowatts per meter squared. So if I input 500 here, that's actually a mistake because it's going to be 500 times 2 by 2 meters is 4 meters squared. So 500 times 4 is 2,000 kilowatts, and that's 4 times bigger than I want. So what I need to do is divide 500 by 4, 125. So 125 times 4 is 500 kilowatts, and that's exactly what I want. So my fire is defined. The next thing I want to do is open the 4 sides of the domain. And to do that, I'm going to type ampersand vent. This time MB equals to, MB stands for mesh boundary, and I'm going to type xmin, and I'm going to type surf underscore ID equal to open. And this is a built-in surface that is open to ambient conditions. So I'm going to copy this and paste it 3 more times below, and I'm going to change here xmin to xmax. Here I'm going to change this to ymin, and here I'm going to change this to ymax. What this does is give me an open boundary condition at the left, right, front, and back sides of the domain. And the last thing I'm going to do is add in my output quantities that I want to see. There are a couple of default ones, but I want to add in a few. So I'll type ampersand SLCF PBX equal to 2.0 and quantity equal to temperature. What this does is allows me to see the gas temperature at X equals 2.0. That's the middle of the room. between 0 and 4. So if I copy this, paste, if I change this to PBY, now between 0 and 4 in the Y direction, I'm in the middle of the room, also showing the gas temperature. The last thing I want to do is add a boundary file, a couple of boundary files. bin, so I'll type ampersand bndf, and here I just have to type quantity equal to wall temperature, and that's going to paint the surfaces of the model with the wall temperature. So if I copy this and paste 2 more times below, I'm going to change this quantity to net heat flux and the following quantity to radiative heat flux. There we go. I'm all done with the input file, ready to save and run the model. So if I go to File, Save, if I start in the desktop, I see my room folder that I created, and here I'm going to name the file room.fds. And you'll notice I matched the file name to the CHID. It's not required, but it's helpful to be consistent between those two. I'm going to change the save as type to all files so I don't get that .txt on the end, and hit save. So if I open my room folder, I see the one room.fds file that I just created from scratch here, and now I'm ready to run FDS on this file. So if I go to Start, Run, type CMD for command, and hit OK, I'll get a black command prompt window, and it puts me in Documents and Settings and my user folder, which is Administrator. Now I can type CD space desktop and hit enter, CD space room, which is the name of my folder, and hit enter. And now I can type dir enter, and I'll see room.fds, the one file that's in there. So now I've installed FDS and rebooted, and I can type fds5 space room.fds. So if I press enter, the model will actually run, and in a few seconds we'll start printing information. So I get the version number, the job title, the job ID, and it's going to print time step and simulation time information. So since we put in 900 seconds, it's going to continue running until it gets to 900 and then stop. Now, while the simulation is running or being calculated, I can actually go over to this window and I'll notice a bunch of files that have been created. These are output files from FDS. Smoke view, there's some CSV files to look at, an out file. I can actually double click the smoke view file while the model is being calculated, and it'll show me the data up to that point that it's calculated. So if I double click, in a few seconds I get a smoke view window, and here is my model. And what I have is a 4 meter long, 4 meter wide, and 2.4 meter high domain. You'll notice I can see through the 4 sides. That's because the boundary conditions are open, and the ceiling and the floor are default or inert boundary conditions. And there's my 2 by 2 by 1 meter high obstruction in the middle, and it has a fire surface on the top. I right click now and go to Load 3D Smoke. These are 2 output quantities are default when there's fire present. So if I click HRR-PUV, that's heat release rate per unit volume, I can see the volumetric flame shown here up to about 10 seconds. If I right click, go to Load 3D Smoke, and click Soot, I can see the soot output, and the model loops in smoke view. If I go to Load Slice File, I have temperature, and I have 2 slices that I specified, 2.0 in the X, 2.0 in the Y. So if I click X, there's the X equals 2.0 slice, and if I click Load Slice File Temperature Y2, I get 2 slice files shown simultaneously with the temperature bar, color bar shown on the right. I'm going to right click Load, Unload All, and show the boundary files. Load Boundary File. I can show wall temperature, and this paints all of the surfaces. Right now they're 15 degrees Celsius. Right click Load Boundary File. I can look at the net heat flux and actually look at that heat flux to the surface. So that's how to run a basic FDS file and view the results in smoke view with some basic output quantities and obstruction, a domain, and a 10 centimeter grid size.